We also need to learn another concept, which is called a complement. So complement of event A, we use this notation, A bar. So A bar means all outcomes which event A does not happen. So A bar means A does not happen. So we will talk about more properties of complement next section. Here we just check an example to help you understand what's the complement of an event. So here we go back to check the skydiving jumps example. Okay, this time we want to find the probability of not dying. Remember the first example we talked about the probability of dying. So here we want to find the probability of not dying, which means it's just the complement of dying. If dying is event A, then not dying is our A bar. So how can we get the probability? We still use the relative frequency method. So first, because this time we are talking about the probability of A bar. So if we treat dying as then A bar is the probability of not dying. So for the formula, the numerator will be the numbers of not dying. If we already know the total number of jumps and we also know there are 21 deaths, we can use the total number minus 21 to get how many jumps are survived, right? And divided by the total number of jumps, we will get the probability of A bar not dying. So the interpretation will be this last sentence. So this rare event rule is very important, especially when we talk about later in chapter 8, when we do the hypothesis test. This one actually is the foundation. Okay, let's check what is rare event rule. So if we have an assumption, we have a statement, we have a claim. With that claim, we get a very small probability. So the probability with that assumption or with that condition is very small. So we can say the assumption is probably not correct. The assumption is not correct. So first we have an assumption and a condition or a claim, a statement. But if we use that condition to get the probability and the probability is very small, then maybe the assumption is not correct. And we also need to learn how to use the probability to determine a result is significantly high or significantly low. Remember, in previous chapter, we learned how to use range rule to determine a value is significantly high or significantly low. We also know how can we use z-value Remember, z-score to determine a value is significantly low or significantly high. But after we learn the probability, we have a new method to determine a value is significantly high or significantly low. Make sure you can understand it well, because this is maybe the most difficult part in this chapter. Probability of x or more is less than or equal to 0.05. So first of all, we check this sign, less than or equal to 0.05. So from the meaning of values of probability, we know if the probability is less than or equal to 0.05, which means this event is very unlikely to happen, right? If the probability is less than or equal to 0.05. So this means x or more is very unlikely to happen. It's very difficult to find this situation. So if we cannot find, or we are not easy to find x value, or any value even higher than x, which means x value is already very high, because it's very difficult to find this situation. Then we can say x is significantly high. Okay, first we should know this sign, less than or equal to 0.05, means the probability is very small, which means the event is very unlikely to happen, which means x value or any value even higher than x is very difficult to find. Then we will say x is already very high, so that's why it's difficult to find such a high value. We call x a significantly high number. Of course, similarly, we can also use the probability to determine the value is significantly low or not. Make sure you see the sign here. No matter we talk about significantly high or significantly low, their probability always less than or equal to 0.05. You will never talk about a probability greater than 0.05, always less than or equal to 0.05. But this time, we talk about the probability x or lower, which means this case, this situation, is very rare to happen, which means it's very unlikely to find x value or any value even smaller than x. It's very difficult to find such a low value like x, or values even smaller than x, which means x is already very low, right? It's very difficult to find such a low value. Then we call x is significantly low. But watch here, no matter significantly high or significantly low, the probability is always less than or equal to 0.05. So just review the probability basics. So first of all, probability is a value between 0 and 1. The lowest possible value for probability is just 0, means the event never happens. It's impossible to happen. And the highest possible value for probability is just 1, means this event is certain to happen, must happen. So impossible, 0. Certain, we will have 1. And we use this notation PA to denote the probability of event A. And we use PA bar, means the probability event A does not happen. And A bar called the complement of event A. Let's move on to next definition, odds. Okay, odds, you can treat odds is just a ratio of two probabilities. It's just the odds of two probabilities. So we have two kinds of odds. The first one, we call it actual odds against. Actual odds against. So this is how we get the odds against event A. We use probability of A bar divided by probability of A. And most of the time we put odds in the form of A to B. So something like A colon B. And said A to B. Of course, if A equals 16 and B equals 4, we will use 4 to 1, not 16 to 4. If actual odds against event A, we use the probability PA bar divided by PA. Then odds in favor is just flip the numerator and denominator. This time in favor. So our numerator will be probability of event A, and the denominator will be probability of event A bar. So if we know the actual odds against, we automatically know the odds in favor, right? We have another kind of odds. The previous two we call actual odds, but in the casino or when you try to buy the lottery, it has another odds called payoff odds. And this odds is about the money. This odds just about the money. So we use profit to amount you bet, means the payoff odds. It's about how much you will win from your bet. It's profit you earned divided by the amount of your bet. We can check the example to help you understand. So if you bet $5 on one number in roulette, we know the probability of winning. The probability of winning is 1/38. But the payoff odds are given by the casino is 35 to 1. So let's check. First question, find the actual odds against the outcome of 13. So actual odds against 13. 13, if the outcome is 13, means you win the game, right? We want to know the actual odds against winning. So outcome of 13 is our event A, right? Is our event A. So we want to know the actual odds against A. Against event A, 13. So we should know the probability of A bar. So that's the probability of A bar. If the probability of event A, 13, is 1/38, so we get this number from the question. So the winning is 1/38, then we know 37/38 we will lose. So not 13, which means we lose. The probability of losing is 1 minus winning. We will get this. 37/38 we will lose. And this is, denominator is we win, the probability of we win. So the probability of winning is just 1/38. Then we can get this one. 37/1 is our actual odds against. So this is called odds against. Please memorize, we use PA bar divided by PA. Then we talk about the second one. Check the second question. How much net profit would you make if you win? We want to know the profit. So we can know. If it's talk about profit, we should use the odds related to money, which is called payoff odds, right? If it's payoff odds, that's the formula. Net profit to amount you bet. So we can write it like this way. 35/1. And to, net profit. This is the profit. Right? And the amount of bet. So here, what's your bet? It's a $5 bet. So it's easy to get this number. So the profit will be 175. Okay, it's 175. If the question just asks you the profit, then this is your answer. But if the question asks you what's the amount you can collect, so it will be 175 plus 5, because if you win, you earn 175 and you should get your $5 back. So total you can collect 180. But if it's just asking you the profit, then it's just 175, because this $5 is your own money. It's not your profit, right? And the last question is, if the casino were not operating for profit, so it's just a joke. But if it's not for profit, then we will change the payoff odds to 37/1. So let's first check the last question. You use the actual odds as the payoff odds. So from the first question, we know this is our actual odds, 37/1. So if we use 37/1 to replace the payoff odds, we use this one, 37/1, to replace this one. So this will be our new payoff odds. Then we check what's our profit. What's our profit? So we still doing the same thing. This time we treat this one, 37/1, as our new payoff odds, because we want to use this actual odds to replace the payoff odds. This is our new payoff odds. And this is the profit we will get. And we still use $5 as our bet. So this time we will get the profit equals $185. In part B, we know if casino use 35-1 as the payoff odds, we will get 175 as our profit. But if we use actual odds 37 as our to 1 as our new payoff odds, then we actually can get $185. So that's the difference is 185, 175. The difference is just $10. That's how casino earn money. Okay.